Hi everyone. In the last session we have seen two quadrant chopper fed DC drives. In today's session we will see the four quadrant chopper fed DC drives. So it is also called as a two quadrant type A chopper or type P chopper also. So this type of power circuit diagram will give the four quadrant mode of operation, that is forward motoring, forward braking, reverse motoring and also reverse braking operations. Supply voltage is connected with four controlling switches. As we are having four controlling switches, by operating these four controlling switches individually, we can get four quadrant of operation along with the uncontrolled diode switches across the each control switch. The armature or DC motor is connected between these A and B terminals. The conventional notation of the voltage and currents are VA and IA. It is in the positive direction when the current is flowing from A to B, and when the voltage polarity is plus is at A and minus is at B, that is positive voltage. The corresponding armature resistance is RA and inductance is LA and back EMF is E. So if you see that this is also called as a two quadrant type A chopper, means if you take this first leg alone, that looks like a type A chopper, left side type A chopper and right side type A chopper. Combined two quadrant type A chopper will call it as. So we will see the operation of this power circuit diagram. So in the first quadrant, by operating each switch at a time, we can get the individual quadrant of operation. To get the first quadrant of operation, S1 is operated. When you turn on the S1 and turn off the S1, you will get the first quadrant of operation with positive voltage and positive current alone. So to get this operation, S1 is operated by turning on the S4 also. S4 is permanently turned on while operating this S1 switch. While S1 is operated, S1 and S4 conducts. When S1 and S4 are conduct, plus is at A terminal, minus is at B terminal through this S4, and the current is always from A to B through this S1 and S4. During this time, inductor LA energizes in the positive direction. So that's why LA energizes when S1 and S4 are conducting. When S1 is off, the stored energy in the inductor will discharge through this S4, because all other switches are in reverse bias. Only this makes this S4 and diode D2 into the conduction. So it will freewheels through this diode D2. The stored energy in the inductor will freewheels through this diode D2 when switch S1 is off. That makes the armature voltage as 0 because short circuit across the motor. So VA equal to 0, but current is in the positive direction. So S4 and D2 will take the conduction path for the de-energizing of this inductor current. So LA de-energizes through this S4 and D2. Next, with that we can get the positive voltage or 0 voltage, that is VA is always greater than or equal to 0 with positive current. That is first quadrant converter. So next, when switch S2 is operated, we will get the second quadrant operation. When S2 is operated, S2 along with S4 conducts together. S2, when S2 is operated, we need to turn on this S2. When you turn on this S2, see here, when S2 is alone, it is turn on, means supply is nowhere in conduction with the motor. Hence the back EMF in the motor will work like a source. It will act like a source and it will allow the current from B to A in the opposite to the conventional direction. So now the polarity is also IA will become minus IA. So it will charge the inductor in the negative direction with S2 and D4 conducts by conducting the S2 and D4. LA is charged. So when turn off this switch S2, LA de-energizes through this diode D1 and D4, because when switch S2 is off, diode D2 is in reverse bias for this inductor current in the opposite direction, and switch S1 is also off, so only diode D1 is in forward bias. Through diode D1 and D4, it will close the path. That's why D1, D4 are the conduct path for the LA de-energizes. So it looks like a step up chopper or type B chopper because inductor, switch and diode. Earlier it is similar to the step down chopper or type A chopper where switch, diode, inductor. Just if you remember that type A chopper or type B chopper or step up chopper or step down chopper. So it is similar to the switch, diode, inductor means that is buck converter or type A chopper. When it is inductor, switch and diode means that is type B chopper. Okay. Anyway, this is the operation for the second quadrant operation. And when switch S3 is operated, we'll get the third quadrant of operation, that is reverse motoring mode. When S3 is operated, so with S3, the S2 switch also we are turning on permanently while S3 switch is operated. So when switch S3 and S2 are on, the positive voltage, the plus polarity will be appearing across at B and minus is appearing at A. That is opposite to the assumed direction of the voltage. And whatever the current is also flowing in the opposite direction, that is B to A. That's why both voltage as well as the current are negative by operating this S3 switch. So LA will get energized in the opposite direction. In the negative direction, LA will energize. When switch S3 is off, the stored energy in the inductor LA will discharge through this S2 and D4. The stored energy in the inductor will discharge through this S2 and diode D4. So this is one of the path only. There are chances for other paths also to discharge the stored energy in the inductor. But here I am getting this path. This is nothing but to discharge the stored energy in the inductor. S2 and D4 is one of the path. Okay. So with that, your armature voltage equal to 0 because the short circuit across the armature, that makes the VA equal to 0 also. That VA can be negative or 0 with negative current. That's why it is in the reverse motoring mode. Next, by operating the switch S4 alone, S4 is operated, with that we can get the fourth quadrant operation. With S4 alone means earlier when S3 and S2 are operated, the back EMF will be in this direction, minus and plus, because when S3 is operated, your plus is at B, minus is at A. With that, your back EMF will be with plus polarity and minus polarity. It is opposite to the earlier conventional notation. So that makes the, now in the quadrant 4, to get that braking operation, your load will act like a source with the back EMF. When S4 is conducting, S4 is operated, by turning on this S4, the stored energy in the inductor, or it's not like a normal motoring operation. Now it is entering into the braking mode. When braking mode, the source will act like a source, the load will act like a source. Load will act like a source means the load turn on by turning on this S4 and diode D2, the inductor will charge in the positive direction again with S4 and D2 with these polarities of the back EMF. Inductor is charging in the positive direction means the current is positive. That's why. So here current is positive. Again, when switch S4 is off, it need to discharge, right? To discharge the stored energy in the inductor, diode D3 will be in forward bias with voltage and diode D2. That makes the, again, negative voltage only. With negative voltage, with only forward current, that is nothing but armature current is always positive by operating this S4 switch with negative voltage or 0 voltage. That makes the quadrant 4 operation. Okay. So simply here I have drawn, for the similarity I have drawn. Here also when we are turning on, this is source, right? Source, there is nothing but supply, and supply is having inductor switch diode, right? Inductor, switch, diode means it is like a boost converter or step up chopper or type B chopper. Just for similarity I have written here, but this is the operation to get the 4 quadrant of operation. Just in the speed torque conventions, speed is directly proportional to the back EMF is directly proportional to the armature voltage, and whereas torque is directly proportional to the armature current has taken on the x-axis. If we see with the armature, the conventional rotation of the speed is in the clockwise and torque is also in the clockwise direction. Hence, both are considered as a positive speed as well as positive torque. For positive speed and positive torque, the power is positive. Hence, it is in motoring mode. As speed is positive, that is in the forward motoring mode. Once, if it is entering into the braking mode by reversing its armature current, the torque becomes negative. So it is opposite to the assumed or conventional rotation. Torque is negative. By reversing this torque direction, your power will become negative, right? When power is negative, it is enter into the braking mode. With the positive speed, forward braking mode. From forward braking mode to next, if we reverse the speed direction, the speed and torque both are negative. Hence, power is positive. Power is positive. That becomes the motoring mode. But with reverse speed, that's why reverse motoring mode. And next, with reverse speed and positive torque, reverse speed is negative but positive torque like the first quadrant, that makes the power as negative. That gives the braking operation, but as speed is positive, it is reverse braking operation. Okay, so just to understand in a better way, the speed torque conventions are given. So here overall, if you see in the for forward motoring and forward braking operations, forward motoring and forward braking is nothing but quadrant 1 and quadrant 2. Quadrant 1 and quadrant 2 operations we will get by turning on the S4 switch and by turning off the S3 switch. By turning on this S4 switch and by turning off the S3 switch. Turning on the S4 switch means this is simply short circuit, this is open circuit. That gives the type A chopper, right? We are having only two control switches. That makes the S1, S2 are operated in a complementary mode. With that, we'll get always VA is greater than or equal to 0 with IA is reversible, means IA can be positive or negative. That gives the 2 quadrant operation. That is nothing but with this we'll get the first 2 quadrant operations. This is your IA and minus IA with VA is always positive, right? So this already we have seen with the type A chopper, 2 quadrant type A chopper. So that's what we got it here. Next, to get the reverse motoring operation and reverse braking operation, we need to turn on the S2 and S1 is off. S2 is on and S1 is off. That makes the right side type A chopper active, and that makes the, by using this, again 2 control switches are there. The S3 and S4 are operated. When you are operating this S3 and S4, your voltage is always less than or equal to 0 with IA is reversible. Again here, IA can be positive or negative with your voltage is always negative or 0. Whereas you can get either current is positive or current is negative. So with this type of right side type A chopper and left side type A chopper, by operating 2 individual type A choppers at a time. This is left side type A chopper, these 2 controlling switches. This is right side type A chopper. By operating 2 individual type A chopper together, we can get 4 quadrant of operation. By combining this, we can get the 4 quadrant of operation. The corresponding 4 quadrant operation is like this. And with that, you can get all 4 quadrant characteristics in the speed torque characteristics. The forward motoring, that can be extended to the braking mode, so that you'll get the forward braking mode of operation, and reverse motoring, and if you extend that characteristics into the 4th quadrant, that will be the reverse braking operation also. These are the speed torque characteristics of the four quadrant of operation. And there are few applications like the battery supplied vehicles. This four quadrant operation is very important, as well as it has multiple applications, because we required this type of drives, four quadrant drives, only in the real time applications. Most of the applications like battery supplied vehicles, solar and wind energy systems have this type of drives, and electric cars, airplanes or spaceships etc are also used this four quadrant drives, because obviously we need forward motoring operation, and we need to apply some brakes while it is in motoring mode. Then we'll get the forward braking or forward regenerative braking. And few applications require reversible operations also. There reverse motoring is required and reverse braking. Wherever motoring is there we need to apply the brakes also. So few power supplies in computers and commercial electronic instruments also are the applications of these four quadrant chopper fed drives. So this is all about the four quadrant chopper fed DC drives. Thank you all.